Hey, this is OXDF. Today we're doing day 12 of the advent of code 2016, Leonard's Monorail. So there's a bunch of story here, but the real thing is basically I'm gonna have to make a computer and I have to try and handle 4 instructions. So there's copy XY, which copies X into the Y register, and X can either be an integer or it can be another register. So it says up here we have registers A, B, C, and D, and they all initialize to 0 and can hold any integer. So this could be copy 14 to Y to register A, or it could be copy register B to register A. Inc X increases the value of register X by 1, dec X decreases X by 1, and jump non-zero XY jumps Y instructions away if X is not 0. So that'll allow us to do loops and things. And so basically we have an example here. We put 41 in A, we make A42, we make A43, we make A42 again. Then since A is not 0, we're going to jump 2, so 1, 2 to the end, and when it hits the end, it's done. And so now we know that A is at 42. And so that's it. Let's go ahead and check out, get started on this. Genday, day 12, and this is my script that'll create some stub scripts for me to work with, as well as pull my input. I go over it in the intro video. I'll put a link here. Our input is not too long, only 23 lines. There's probably going to be some loops in here. So it's probably more complicated than just the previous one, but we could probably work through it manually and see what it looks like, but let's not start there. Let's see, we are going to use, let's write tests today. We are going to use the file. So I better go ahead and grab this example input, grab this and come back, make a file, new file, example1.txt. I always thought it'd be cool if they would make the example file, like the input you could pull from a specific path. It'd be nice if the example file you could just download as well. Let's see. So we're not gonna use these yet. We're gonna start by doing we're gonna create a computer class, right? So we'll do def test create comp example1. And we want to be able to say, if we say comp equals AOC, so we're referencing back to our file, we're going to call it like .computer, which doesn't exist yet, and we'll pass in example1. And what do we want to get out of that? Well, we have a handful of things, right? We're going to need our 4 registers. I'm trying to think if let's see, we could do like assert comp dot. I'm trying to decide if we want to do like comp.a, comp.b, comp.c, etc., or if we want to have like a reg. I think it's going to be easier down the line if we actually do like a dictionary that's reg. So if we say that of A, it's going to be 0 because we want them all initialized to 0. Assert comp reg. I guess we don't have to do all 4 of them. We'll just, if we get A, we'll assume we get the rest of them right too. So we can say lines, because we're going to need like our program code. We're going to want to store that. We'll say is example1 dot strip dot split lines. So, oops, that's not lines. Basically what we're saying is we want to make sure that the computer's holding the input and it's split and processed and ready to run. We will assert that we're gonna need like a instruction pointer, so I'll call it IP, and it's gonna initialize to 0. And I think that's probably it. We can come up here, let's see, we set this on PyTest, and I went over how to set this up to run PyTest with the debugger in another video. I'll try to include that link. Anyway, and here we go. Let's see. Why curly brackets? That's weird. Save that F5. Okay, so we have failing because we have no attribute computer. Perfect. So now we have something to go make. Let's go make a computer. Day 12.5. So we'll come up here and we will do class computer def under init. And we're going to take in some inputs. We'll call this puzzle input. And if we just stop here and rerun our tests, you'll see now we're getting, okay, it's got no reg. So now we can do our stuff. So we can do self.registers is equal to, and I'm actually gonna I'm gonna use default dict for this. And that'll just give me, rather than having to initialize them all, I can just do from collections import default dict. So now this is a default dict of int. So basically what I'm saying is, give me a dictionary that holds ints, but if I try to access a key that's not there, just return 0. That's what int is. So now if I F5 and run this, we can see, let's see, we are still, computer has no, so we actually, looks like we made it through this first assert, but now we have no lines. So let's just do the last thing here. We can do self.lines, it's equal to puzzle input dot strip, because I want to make sure I get rid of any trailing, and then split lines like that. And I might as well go ahead and do self.ip is equal to 0. Now we pass our tests. So we've got a simple computer object. Next thing we need to do is test our various, we're going to want to make a run, like run self, going to return none. So nothing exciting there. Oh, I guess we could type hint here. Sweet. So what are we going to do? We're going to loop over each of the commands, taking the action it says. So right, we'll say while self.ip is less than len self.lines. So while our IP instruction pointer is less than the lines, we're also going to want to add at the bottom here I plus equals 1 to make sure we're incrementing. That's a mistake I make all the time, and I'm going to get stuck in infinite loops. So we can do let's say t equals line sub self.ip. We better do self.line. So get the current line, and we're going to split it on space. And again, I'm pretty sure that's the default, but I like explicitly staying it. So now we have a bunch of tokens. So now we can say match. Let's take a look at the input, right? The instruction is always the first thing. So if we come back here, match on, let's see, what was it? Copy CPY. CPY. No, that's not what I'm trying to do. Match T0 case CPY. And if it's a copy, we want to, we're going to go from the value and the first value to the next into the register. So we're going to say self.reg sub T2. So we're going to put that's the second register is equal to. And now this is where the tricky part. We need to be able to handle, is it an integer or is it a registry value? And I'm actually going to use a function for this. So we'll say self.get value T1. And that way, because I'm going to use this a lot, I think. And so we can just leave it at that. Now we have a case of, what was it, ink. And so this would be self.reg T1 plus equals 1. And I think the deck case is going to be very similar. And this is just going to be DEC minus. And the last one was case JNZ, I believe. Make sure that's actually the right, yeah, JNZ. And then the number is here. The thing to check for non-zero is this. And again, we're going to need the value. It looks to me like we could use a register or a value. Yeah, because here's a 1. So we'll say if self.get value, and let's go ahead and define this so we have it. Def get value self val return int pass. Cool. Okay. So if self.get value of T1 is not equal to 0, self.ip plus equals int T2. And I think T2, well, could T2 be a register as well? There's really no harm in handling it that way, because if I get a letter, so let's do, instead of int, we'll do self.get value T2. Because if it's always an int, we'll make sure this, if it's an int, get value just returns the int, right? So I think that looks good, although we're not going to be able to test. Oh, we should have written, okay. We have written our tests. Okay, let's come down here. We can do def test run comp example 1, and what should we should be able to say comp equals AOC dot computer example 1, and now we do comp dot run, and now we should be able to assert comp dot reg a equals 42, I believe. Let's also do def test get value. And we don't need any input on this one. We're going to say comp is equal to AOC dot computer. And we're just going to pass an empty string because we're not actually going to use any of the inputs on this one, this test. So that's one of the things when you write tests, you don't need to make everything perfectly realistic. For this one, I'm going to just say comp of, if I say comp dot reg, which would of, let's say, A is equal to 17, made up number. Now if I come down here, I can do assert comp dot get value of A should be 17. If I can do assert comp dot get value of 423 is equal to 423. And so those are that way we're just testing to make sure this get value function works well. I think we're gonna get a fail right now because get value is not gonna, let's see. Ooh, okay, we got some errors somewhere. Let's see, are they in here? I see red lines. Oh, my increment is getting off here. Let's see. I plus equals 1, not I. Self dot IP plus equal 1. And oh, I guess the other thing is if we jump here, we should not do anything. We should not get that +1. So we'll continue. Okay, that all looks good. Let's check our tests. We have 1 passing, 2 failing. So, well, that makes sense because we're not going to run correctly, and get value is not implemented yet. So that's good. That's where we want to be. That's what we're supposed to do. So now we'll implement this. So we'll say try return int val. So we're going to try to treat it as an integer. And then we can accept a value error. We can return a value error. That's what happens when you try to take int of a thing that's not an integer. And we can, if it's a value error, then we want to return self.reg of val. Now if we F5, we have no attribute self.reg. Where are we here? Oh, in our test. Let's fix that. Right there. All 3 of our tests are passing. So what that means is now we've verified our get value function is working as well as our run function. So we might as well just go over here and try to solve this thing. See what happens when we pass it the actual input. We get nothing. Oh, because we haven't actually set this up. Okay. We don't need a parse. I don't really know if we need a part 1 or part 2. Let's just skip that. We'll delete parse for sure. We don't need parse. We are going to puzzle input. We're going to say comp equals, I guess we could just keep that. Computer of puzzle input, part 1. Then we're going to do comp.run. And so solution 1 is going to be comp.reg of A. Part 2, we're going to call for now, we're going to call none. All right, let's run this. Get a value. Check out. It seems very high. But it's right. Okay. Part 2. You heard of, yeah, I'll pause to read. Okay. So this time, all we need to do is after we initialize the computer, we also need to initialize the register C to be 1 instead of 0. This seems far too simple. Let's give it a try though. So we're just back. I don't even know what test I could possibly write for this. So let's just come here. We're going to say comp2 equals computer puzzle input like that. We'll say comp2 dot reg C equals 1. So comp2 dot run and solution equals comp2 dot reg A. And we run this, and I'm guessing it's going to get stuck or it's not going to run very well. We'll see. I guess we'll give it a second. I guess while we do, we can go here and try to figure out what is changing C due to our input. So Copy, 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 jump non. So right here, jump non-zero, C. So C before was 0. Now it's going to be 1, so it's not going to jump here. Or it is going to jump here, sorry, it's going to jump 2. So instead of going to this jump, which goes 5, it's going to skip to here and do this stuff that was before not done. So in case that's not clear. So before, with C was 0, we're going to go copy, copy. Oh, we got an answer in reasonable time. Copy, copy, copy. We're not going to jump here because C is 0. And we are going to jump 5. 1, 2, 3, 4, 5. So we get to here. And we avoid this loop. And this is a loop, copy 7 into C, increment D, decrement C. So C goes down to 1. And that doesn't seem too bad. Okay, there's probably some more of these. Non-zero C. Here's another one. I'm not sure. But anyway, we got an answer. Let's go try it. Sweet. Man, yesterday kicked my butt and today was like a piece of cake. So I guess they aren't getting harder necessarily, or they're not linear. Thanks for hanging out with me today. I will talk to you next time. Bye.